All right, let's get things started. So hi everyone, my name is Chris Doran. I am a technical sales specialist for Global Test Supply. Thank you for joining us for our webinar today, brought to you by Global Test Supply University. Today's topic is NFPA-70B Safety and Compliance with Teledyne FLIR. We'll be covering a good amount of information over the next 40 to 45 minutes or so, and we'll have time allotted at the end of the presentation for Q&A. We do encourage you to ask questions throughout the presentation. If a certain topic is being covered on a slide or anything that gets your questions going, please use the question feature and type them in immediately. And as mentioned, we will address them during the Q&A allotted time after the presentation. Global Test Supply and Teledyne FLIR have been working closely together for many years. We pride ourselves on being a leading distributor of Teledyne FLIR in the US. This is a result of our dedication to offering you our product expertise, service, and competitive pricing. Getting started today, today's webinar is presented by John Gould, Director, Global Business Development for Condition Monitoring. John, I will turn the presentation over to you.
Great, Chris, thanks for the introduction, and thank you everyone for joining today. Okay, we'll get started right here. All right, so just wanted to go over an agenda for today. There's a couple different components. Wanted to bring into the discussion a little bit NFPA-70E, which many folks are familiar with around different electrical safety programs. And kind of how it ties back into 70B. We'll talk about that in a little more detail. Brief overview on thermography, so just some of the basics around it, why it's important, how it works, and really just to provide a little bit of context when we start talking about the different requirements on 70B for thermal inspections. We're also going to talk a little bit about value and benefits of adoption for 70B, because this is an important topic that, regulations and requirements are many times about following the rules and complying with standards, but there are some overarching benefits for adopting this inside organization. We'll talk a little bit about how we can help the different tools and services we offer here at Teledyne FLIR to be able to support your efforts in your electrical safety programs, as well as Chris mentioned before, any questions that you may have. Please do encourage you to use the chat box to document as you go through, so we can capture those questions, and then Chris will act to moderate those at the end of the session. Right, with that being said, let's go ahead and get started. All right, so the 70E, the electrical safety program itself, really consists of 5 core components, really getting into understanding where this is about keeping people safe, right? Whether it's through qualifications, understanding the different hazards that are possible within your electrical equipment, doing those assessments, preparing jobs and job planning, as well as leading towards some of those reliability efforts. We're going to dive into those in a little more detail here now. So as it pertains to qualifications, it's just important to call out the very specific language that the NFPA uses. When we talk about qualified people, we're talking that they should be trained and knowledgeable in the construction and operation of equipment, as well as be trained to identify and avoid the electrical hazards. So many organizations will have safety programs around electrical safety, but really understanding that staff who are interacting and operating on these electrical systems should really have full understanding and knowledge on the construction and how those pieces of equipment work, and tying that back to their ability to identify and avoid those hazards. Important call out here too with 70E is that you can be qualified, but also not qualified at the same time. And what I mean by that is you can be qualified to perform certain activities or tasks while still being considered unqualified with respect to other tasks. So when we get into some of the job planning and safety plan aspects of the activities around working on energized equipment, in particular, you may be qualified to perform certain tasks, but not qualified to perform others. And it's really important in whatever system you're using to document qualifications that folks understand where they tie into what skill sets are necessary for certain tasks and how you're building those plans out in accordance with their abilities. You really don't want to put someone in a position where they're not going to be operating or performing in a safe manner. Getting into the assessment side, and many folks who are attending today, the folks who are the end user base who are involved with the actual activities in these things, understand that we really need to be able to document any of those hazards that are possible with the equipment and performing risk assessments, right? So how and what is the likelihood that that event would happen? Typically, we focus in on arc flash as a predominant safety activity in terms of being protected against and performing tasks in a safe manner, but also the severity of the event and understanding what is the consequence of that failure should it happen, both to persons and property. There also are requirements around the different system studies, so understanding arc flash studies, short circuit and coordination studies in particular, where you want to be sure that those studies have been done on your equipment to understand what are the hazards and how to prevent or work around those. And the hazards themselves, really what we're talking about when it comes to 70E is, what are the various types of PPE that are required, the tools, the insulated tools used to operate on that equipment, as well as test equipment itself that you're using to perform continuity, installation, measurement type testing, as well as barriers and understanding what are the needs that I need to equip my staff to be safe and to be protected from any hazards. And we can see on the bottom of the screen here, we have the approach boundaries where you can understand, limited approach down to zero distance. These are all very clearly defined in 70E based on the type of PPE, as well as any necessary barriers or type of equipment that you'd want to use when performing any sort of testing or inspections. And then moving into job planning itself, right? So understanding where we're documenting the tasks that be performed, as well as identifying hazards. Many organizations will lean back to or leverage what are called hot work permits or energized work permits that detail out the different specific tasks that need to be performed, who's going to perform them, when they're going to happen, what are the necessary lockout and tagout procedures that need to be followed. And those are all typically a part of an energized electrical work permit, but also that job safety plan. That's going to be a separate document that details how you're going to handle the job plan, job safety itself for that particular activity. So I really wanted just to bring these up to just kind of set a foundation for the discussion where we're talking about the differentiation between both 70E and 70B. We're going to see elements in 70B that reference back to some 70E components. So as you're having those conversations with the customers, not only about the PPE requirements, but also as it pertains to developing a good safety program around your electrical maintenance. Okay, with that, we're going to kind of shift gears a little bit over to infrared and just kind of give a basic understanding of what that is and kind of why it matters into the context of these inspections. Just a kind of little refresher for those that don't have engagement or understanding just at a high level. We'll give you some good examples here. So really infrared cameras, they're a non-contact device, so considered non-destructive testing tool that detects infrared energy, so any heat, and converts that into a signal. So the sensor will convert that heat to a signal, and it's going to be processed into to be able to be produced into a thermal image. So what really happens here is we're talking about the heat radiation detected on the sensor. We're using some calculations, the Stefan Boltzmann law, to really define what the measurement values are, and what we're producing is a temperature range or temperature measurement for each pixel on that camera, which is associated to the sensing ability. The heat sense is really going to give you very precise, quantified values, and it's going to allow you not only to monitor thermal performance, but also identify and evaluate the relative severity of heat-related problems. So what we do is we take those measurement values from a data perspective, and that's when we produce that radiometric image, which takes and produces a visual of all of those spot temperatures that we're seeing. We've got a nice little herded deer here as an example. Everyone's seen a picture of a pump or a motor. I'm going to have to throw something in here a little different just to give you an idea of what we're talking about today. And what is it more, it's really about the process of turning that radiation into a usable picture. Right? When we're talking about thermography. You see the tank here on the side. We can't tell how hot it is or any problems that may be having, but once we have a radiometric image, we can actually see where there may be heat signature where there may not. So what it comes down to, why do we need to see heat? Why is this important, particularly in an electrical application? It's really about being able to identify problems, right? So this picture on the left-hand side here, this is a fuse clip, 3 fuses. We can see on 3-phase power, we can see each phase with this particular example. And why do we want to see that, right? To be able to identify potential failure before that fuse fails, before there's an issue, and ultimately avoiding this situation, right? It's a substation that has blown up, could have been a variety of different reasons. It's usually an issue with insulation within the transformer, oil leak, different gases within the transformer igniting, but being able to identify those heat issues before it becomes a problem, and really moving towards the model of predictive or preventative versus after the fact, right? Finding out issues, we want to predict that problem before we have an actual issue. So yeah, we're looking to find problems that increase safety, both for the site and for the people who operate in it. But really the ultimate goal is about preventing that consequence of failure. And I encourage you, when you're speaking with those end users and customers, understanding the types of equipment that they're performing inspections on and doing maintenance on. What if that piece of equipment failed? What would the impact of the business be? And it really helps to quantify an investment into a good program around predictive maintenance, where thermography is certainly a component in aiding that effort. Transition a little bit into kind of the actual resolution on the image itself. And really just the basis of this, or the basics, are that more pixels within an image is going to equate to higher density of measurement points. With a regular visual camera, the more pixels you have in your image, you're going to have an image where you can zoom in a lot further, get a lot more detail. It's probably the best analogy to use. So we have a grid here, which is kind of a standard image of a set of pixels, if we wanted to use that as a reference point. And we can see here with this other image, we're going to have a lot more pixels inside the same image. And this is a good visual example. We have 2 different temperature guns with radiometric image showing here, and we can see the differences in the 2, where one has many more pixels on the target versus the one on the left that has far fewer, and less pixels is typically going to result in that lower quality image. And when it comes to electrical inspections, and understanding, you have spacing of your breakers in this breaker panel to be able to isolate things more effectively, to target the issues in a more meaningful way. Having more pixels on target that are sensitive enough, we can really stand to benefit from having the right tool within our electrical inspection. Then resolution and accuracy, right? So this is another component to the more pixels on target discussion. So here we're looking at a series of motor banks, and there's a spliced wire, and we can see kind of at a very high level, we have a hot spot, if you will, on that splice. But really, if we take this down to a more pixel level, really going to help us tell the story, right? So here we have, a larger pixel set where the average temperature data from that single pixel is 79.1 degrees Fahrenheit. If we start to get more pixels on target, we're going to actually start to get a better measurement of that activity. So we have, in this particular case, with more pixels on target, an average of 98.7 as we go. And then if we take it even a step further, right, we have more pixels on target, we're getting more accurate. So within that splice, we can actually see that 119.3 degrees is really the focal point of issue for that particular component. And if we went back to the original, we have a very large discrepancy with our temperature readings from a lower resolution or less pixels perspective to the more pixels being our target. We're getting a more true reading. And why is that important? When it comes down to electrical inspections, you're going to have a variety of different applications and uses. You want to make sure that the camera that you're using for these thermal inspections is the appropriate camera to be able to effectively target and identify issues within your electrical systems. Transition a little bit out of the science or the back of thermography and understanding that, really just now driving it a little bit more to some of the arc flash safety. So 70E, we talk a little bit about a lot about, the PPE, the safety requirements, the distance away from danger relative to arc flashing. Really wanted to bring into the discussion the importance of IR windows. And all of these things kind of come together when it comes to 70B, which details out the inspections and the frequencies of inspections. So just bringing these topics up to help understand where there's some benefit or opportunity to not only align camera-based thermal inspections, but what other supplementary tools do we offer here at FLIR to help assist those customers who are making that transition or performing these NFPA-B required inspections. So with arc flash safety, we understand the variety of different causes. So as you're in your 70E program, you're going to have to document out the different means by which hazard could exist within that operating environment. We can see here everything from cover removals, animals being in your cabinet, faulty wiring, human error, people not being safe, not locking out a particular piece of equipment before they open something, a variety of different ways that can happen. And then ultimately, as a visual, this is what an arc flash looks like. And if you're standing in front of that without the appropriate PPE, it can be deadly, if not severely injuring the individual who is operating on that piece of equipment. So I just wanted to give you that little visual there. Hopefully that came over the webinar clear enough. And then just electrical safety, tying this all back together, the guides are providing documentation for safe work practices and the safety equipment, safety requirements for those electrical engineers. And really that safety and efficiency are the main factors, right? So as we're talking about avoiding arc flash injury, we want to make sure that we're first and foremost doing so in a safe manner, but we need to be efficient. And anyone who's donned a PPE suit for high voltage inspections will tell you it doesn't make you very efficient, right? It provides, it's a little bit cumbersome. There's a process to get dressed and involved. There's a lot of permitting involved with ensuring that someone knows where you are, you're operating with someone else, you're operating at appropriate distances. I really just want to kind of return that discussion back to safety, right? So with IR windows or infrared windows, you keep the door closed, right? So workers are staying isolated from that live switch gear. They're still able to perform their inspections, and then reducing risk in the hierarchy of controls. And hierarchy of controls is really just driving into some of the standards that the NFPA set, where you are having controls in place over your environment to ensure that you're maintaining safety for those who are performing tasks and operations. So really to improve the safety, we're focusing on keeping those doors closed, keeping that high voltage isolated away from our inspectors, and really wanted to talk about a case study here that we did here at FLIR with one of our customers. It really kind of helps tell the story, right, around IR windows and why this is important. So we did an analysis for a paper mill. So a lot of times people will ask, John, it's wonderful. IR windows totally make sense. I don't have to put on my arc flash suit. I don't have to wear the funny hats. I can go and do things nice and efficiently, but I need to justify the cost on this, right? So what we did with this particular organization is a paper mill. They have about 150 pieces of primary switchgear. They're doing annual inspections. And they're using a combination of infrared and ultrasound, and they're done on currently energized equipment, and that's how it needs to be done. But it's also being done in full compliance with both 70E and 70B. So kind of just setting the story here, right? Setting the as-is situation. The inspections done by 2 plant electricians is very common. Usually work in pairs when you're dealing with high voltage inspections. Removing the panel for access, and then 1 contracted reliability center maintenance engineer who's actually performing those inspections. And they take about 150 hours in total, so about an hour per piece of equipment over a 3-week period as scheduling kind of allowed this to be performed. But kind of just breaking things down, right? So this is kind of to understand the time invested in this type of inspection. And what we're we're talking about with this inspection is an inspection that is required for NFPA-70B. So this kind of feeds right into that need that organizations have, where they're going to need to go out and do these inspections as a part of being compliant with 70B. They're going to have to do them at a minimum every 12 months. And this is hopefully helping to kind of paint the picture for some of the challenges that your customers and clients are going to have in this space. So we have at the top here, operationally, the RCM engineer and the electricians suiting up into their equipment, their PPE to go out and perform those inspections. Operationally, they're removing the cover. The inspection is happening. They're putting the cover back on. The RCM engineer has to wait around while the electricians are putting that cover back on and taking that cover off. And the electricians, they're going to be waiting there while the RCM inspector is performing their task. So if you take a look at the manpower totals, it's about 495 hours for that particular actual inspection activity, with a total of 558 hours being spent. And these are real numbers. These are numbers that were quantified in working with this customer. We had them document in time how long these things took. And really what this comes down to, 543 of those hours, 97% of them are in dangerous, high risk, or unproductive labor situations where their panel is open to energized equipment, or they're standing around waiting for another person within the work process to do their task. And it's very clear to document it. And they've been doing this for years. This is a process that they've done every year annually because it is of critical importance and a part of NFPA-70B compliance. But let's take a little bit of a look. So we went and we installed IR windows in 150 of these different pieces of switchgear what they need to inspect. Let's start to look at the numbers now. So no longer do those inspection team, both the electricians and the RCM engineer, need to put on their arc flash suits, right? Because now we're using the IR window to perform the inspection. We don't need to take the cover off. We don't need to have people standing around anymore to do any waiting for the other person to finish their task. So we took what was a much longer duration event and took the manpower down to 30 hours. And if you were to perform some calculations with your customers or end users to understand, how long is it taking today to do these activities and what would the difference be with IR windows, I can tell you with absolute certainty that those IR windows are going to pay for themselves after the first inspection, if not the second, right? So it's a safer way to do it, and it also is going to produce a better work outcome for the organization. And EMSD, that's the Electrical Maintenance Services Department. So using that staff, we actually came back and interviewed them to determine that these numbers are accurate. And really that's now, we've shifted a lot of unproductive, unsafe work hours to total productive time. Right? This is really important as we kind of enter in this discussion where you have compliance needs with 70B. The more I can do to ensure productive work time when it comes to performing electrical thermography inspections, the better. And really kind of breaking it all down. So they went from 558 man hours using three-man inspection team, now down to 30 hours. It's a real world savings of over 90% of the hours needed to complete this task. And really this is what it looked like before when they were doing that. And now with the implementation of IR windows, it's one person who's performing that task. All of these windows are UL certified and certainly can talk to the details of those. And Chris and his team at ITM can certainly speak to the benefits and right application in much more detail. We also have a series of circular round windows. So we offer different sizes to accommodate what your targets are inside of your cabinets. We have a lot of organizations that are deploying this on things like control panels, switchgear, certainly, access to certain bus bars in grounded neutrals. I mean, you name it. There's a lot of different places where you can put this on a wall. You can put this in, in the actual cabinets themselves. just to understand we're trying to improve the inspection time as well as keep our staff and those inspectors safe in the process. Also offering those large format, what we call large format windows. So depending really on what you're inspecting, we have a solution that can meet the needs relative to the type, size, and placement on those things as needed. We are seeing also a lot of manufacturers that will actually start installing these IR windows at the factory as part of customer requirements for any new equipment that's being installed, with that end customer going and performing the installations of the IR windows on existing equipment as well. So we have warranties information available as well, but this is really a great solution for customers who are working towards creating a better inspection program as it pertains to both compliance and also improving reliability, which kind of leads us now into 70B. So with regards to NFPA-70B, I pulled this comment here directly from the literature. The purpose is of the standard to provide for the practical safeguarding of persons, property, and processes, and the risks associated with failure, breakdown, or malfunction. And it means to establish a condition of maintenance of electrical equipment systems for safety and reliability. So we can see here the language is slightly different from 70E in that we're talking about safeguarding of people, property, and process, really about the maintenance of electrical equipment and systems for safety and reliability. The two work in concert. 70B's focus is much more on the correct and effective maintenance practices around electrical inspections and maintenance. So really, focusing in on what's new, right? So key takeaways that I kind of wanted to highlight here. The document itself is providing guidance that affects process, procedures, and documentation, right? So understanding very specifically what those changes are. We work with organizations all the time that are aware of 70B, but we're not aware of the changes that came out. Those changes came out in December of last year for implementation as of January in 2023, and are slowly being adopted into other regulatory agencies as the standard by which is referenced when it pertains to electrical maintenance and inspections. The big call out for us here at Teledyne FLIR was that thermography has moved from a recommended practice to a required practice. And that's a big shift within the guidance, where in the past it was something that they recommended that you do. Now they very explicitly call it out as a required activity and task. In the guidance itself, if you look at the documentation of recommended maintenance activities, regardless of the asset type that's being maintained, the very first line on that list of activities is a thermal inspection. So we're going to get into the specifics on these a little bit more. So within the procedure side, we might mention that moving from recommended to required. Also some condition-based requirements. So there's three different categories that NFPA references. Category 1 being equipment that is in a state of good repair and does not have any material issues relative to failures. That condition 1 asset at a minimum is required to be inspected annually. Moving down the category ladder to 3, where you have a condition that is not in good condition or is in a failing state, the inspection requirements will be increased to every 6 months. Additionally, within category 2, if you did not perform your annual inspection, you need to perform that inspection every 6 months until you're brought back to current. And then the detailed procedures by asset class, those are all included in the documentation. The people side, we have a role defined within the document about the electrical maintenance program coordinator, as well as address some qualifications of both the testing personnel and of the thermographer themselves. We'll dive a little deeper in that. And then the documentation piece. This is always an area where organizations struggle, regardless of electrical inspections or otherwise, maintaining good documentation. So we're going to call out within this presentation today about a little bit about delta T, or temperature differences, as well as the test records required for documentation, as well as calibration, test tool calibration requirements. kind of getting into the procedural side. So what I did was on the right-hand side of the screen, the blue boxes, is I put in the actual section numbers for each of the areas that we're talking about. So 7.41, 9.31, and 9.2.2. Those sections, this is directly taken from the NFPA-70B guidance. So when we're referencing the left-hand column, what we're talking about today, you do have something that you could yourself go pull it up and say, okay, John was discussing this in our presentation. Let me actually go see for myself. So just wanted to give it to you. I'm not going to read this all to you because it's a lot to read, but more want to call it out. So that recommend to required piece, as we talked about before, is in 7.4.1. In the verification of temperature, it's important to call the two different means by which they're looking to do this. So similar electrical components under similar loading, I'll talk to that a little bit more, and as well as comparisons between electrical components and ambient air temperatures. So either of these two methodologies are appropriate to use when requiring any of those differences in temperature. From the similar electrical components perspective under similar loading, NFPA-70B requires that the load be no lower than 40%. So the load of the equipment needs to be at least 40% to be considered in the testable state, as well as any other components that you're performing comparison against have to be under similar load. Right, so it's just important to call that out when we talk about proper execution of a electrical inspection. The condition-based assessment performed and tracked over time. Right, this is that physical condition assessment. It needs to be documented in your electrical maintenance program, and it needs to be established with those various requirements in 9.3.1.1 and 9.3.1.3. If you're feeling like you need to take a nap later this afternoon, I encourage you to pull that document out, have a read. It'll help. But those are the areas with those rules that are required for compliance there, and just understanding what we're talking about when it comes to condition itself. And then detailed test procedures for all equipment requiring maintenance. So many organizations and standards will reference manufacturer recommendations, but within the NFPA guidance, when those recommendations are not provided or available, and if the failure, breakdown, or malfunction equipment present an acceptable risk for personnel or environment, they provide a very detailed list of activities and intervals within table 9.2.2 based on the condition of that asset. So basically it's going to provide you, here are the tasks that need to be done from an electrical maintenance perspective. Here's how often they need to be done based on a category 1, category 2, and category 3. So it's very explicit. It provides some really good guidance for organizations that are looking to engage or get started on this effort. And really important to note here, just to tie it all back together, at a minimum, regardless of condition, every 12 months will be required for these inspections. And really, why do we do this? Is that you're absolutely going to find issues thermally before you find them visually, right? We all know this. We can see those temperature differences and be able to track them over time to see the changes that are made. And shifting a little bit over to the people side. So there's a role that's very clearly defined in NFPA-70B, the Electrical Maintenance Program Coordinator. This is a role, it could be a plant manager, it could be an electrical supervisor, it could be an electrician. Regardless, it needs to be defined within your electrical maintenance plan, and that person is ultimately required for evaluating the electrical equipment and systems and defining that scope and frequency of maintenance. So your electrical maintenance program is going to be governed by this individual and needs to take into consideration all the condition assessments that are needed, as well as defining scope and frequency of maintenance. And I'm pointing this out, this is not just thermography, right? This is programmatic around electrical equipment maintenance. And it's going to vary at different organizations, but it is a required portion of the standard. Personnel themselves should be qualified to perform those test procedures on specific equipment to be tested. This really dives into someone be able to perform the maintenance tasks relative to how to perform the tests, understanding how to use the equipment, what PPE they should be using based on the requirements within 70E, as well as understanding hazards of the equipment that they are working on. So personnel being qualified, you need to document this. You need to have a very clear understanding of when you're aligning your maintenance activities, that people are appropriately aligned and supporting what is actually happening. And then the personnel should be qualified to operate the equipment itself. So any test equipment, we're not just talking about thermal cameras, could be any component of it. They need to be properly qualified to execute on those tests. And now moving into the documentation side, right? So Delta T requirements for all thermal testing, we already called out those specific things, but that comparison between electrical components and ambient air temperatures, it needs to be under similar loading, right? It's very important, and things that we can talk to a little bit more in depth, but it's not just the thermal image, right? It's understanding what the operational load is of that piece of equipment relative to its actual inbound load on a three-phase system. You need to be able to document those things so that you can have a good comparison when you're performing your testing procedures. Maintaining those records themselves, including as found and as left results. So 8.6.2 gets into the test records of what actually needs to be included in a test record. There's a series of 12 or so different specific line items, but the one I'm calling out here is indication of as found and as left test results where applicable. Really what this is pointing to is we did our thermal scanning, we went out and did our inspection, we found a problem, we made the repair. We also need to document thermally the repaired activity or as left activity. So when you're talking with customers who are bringing in outside vendors to do your thermal inspections every year, you're actually now required to document the as left test results. So if the person who's performing the repair activity or the maintenance activity is not equipped or understands how to perform a thermal inspection, you're going to have to bring that vendor back out to do it again, and there's going to be some cost there. So there's more reason now to have folks who are doing these activities and maintenance activities to understand how to use thermal camera, to be certified level 1 thermographer, to be able to perform those activities as appropriate based on maintaining this documentation. And then lastly, within documentation is equipment calibration. It needs to be traceable to the recognized national standards. One of the standards that they reference within 70B is NIST, which is a common standard used for calibrated equipment. And I'm pointing out here as well, this is test equipment that provides measurements. So clamp meters, multimeters, anything that's used in an electrical inspection program, as well as thermal cameras, need to be calibrated based on the manufacturer's recommendation, as well as documented within the system. So you can't, use a camera that's not calibrated and expect to produce a report that's going to be in compliance, because who knows whether or not that camera or that multimeter is operating correctly. So those are some of the very specific call-outs in terms of, the key impacts within the documentation for 70B. There's a litany more of information within 70B that is of importance and of value to customers, but these are really the key changes in calling these out so that organizations understand, what do I need to do? And why does this matter? And it really leads into kind of the next part of discussion. Why should I adopt this? There's a variety of reasons. One, because you really need to, but there's some others as well. And really what we're talking about with 70B is that commitment for an organization to safety and to a state of good repair. So assets operating to meet their intended design output, whether it's you're producing something in manufacturing, you're running an HVAC system inside of a facility, whatever the intended purpose of that asset is, we want to make sure that those things are maintained in a state of good repair, but doing so in a safe way. And really focusing in on safety as a core to your electrical program. And really that is the combination of people and assets, right? It's not just about keeping our people safe, it's about keeping our assets safe and operational as well. Obviously, personal safety is most important in all cases, but tying these together, it's really critical. It provides a programmatic approach to maintaining that equipment. The standards are very easily defined when you look through the documentation. It's very clear what needs to be done and when. And for organizations that are looking to build a program or maybe lacking in certain equipment that they're not inspecting with the appropriate frequency, it spells it all out very clearly. So it's very, very simple to apply to the organization. And really, when we're doing the appropriate level of maintenance and we're maintaining that equipment based on those standards, we're going to see improvements in our asset reliability. At the end of the day, safety being the most important thing. I follow a gentleman named Mike Rowe, who's from the show Dirty Jobs. I'm sure many folks are familiar with him. One of his mottos is safety third, right? Why do we say safety third? Well, when you say safety third, people stop and think about safety. When you say safety first, obviously everyone thinks safety first, but the safety piece is important. Additionally, getting those improvements in your asset reliability when you're doing the right tasks at the appropriate intervals, people who adopt these programs will start to see improvements in those areas. And then lastly, maintaining compliance, right? So key regulatory agencies, we're going to start to see OSHA adopt 70B components within their enforcement activities. So electrical issues or workplace safety issues as a result of electrical failure, fire, arc flash, they're going to lean to their guidance to make sure that you can produce the type of reports and compliance relative to 70B. That's going to come. We know this is happening. Another area is insurance companies, right? Within the policies themselves, many times the language is loose in this area where it just says comply with key industry standards for the proper safekeeping of assets under the policy. Well, you're going to start to see things more specifically called out. So it's an area where insurance companies are looking at this as the standard, and the organization has a policy with that provider. They're going to need to make sure that they check with their policy and determine, are there any changes to my policy in the underwriting side of things where I have some new language that may affect the need to maintain compliance. So these are all kind of some real value points or some benefits of why you would want to adopt these things, not just for the sake of doing it because the standard says now you need to do thermography, but you're just going to really start to see some overall improvements to the organization. And then how can we help? Right? How FLIR can help. And really this is kind of where we've partnered with organizations such as Global Test Supply, a great partner of ours for many years, where you can go to Global Test Supply and work with their selling team to find the right solutions for your customers relative to the different components that we here at FLIR offer. So it's really three main things, and the last one is probably four, but we'll talk to the first three. So the cameras themselves, we want to make sure that the teams have those right tools to perform those inspections. We also have software to support the reporting side of the business, to be able to take all those inspections and create proper reports. And one thing I will add, we have some new functionality that was recently released with our Thermal Studio Pro platform called reference imaging, where it's a part of our route creator tool that allows you to associate previous inspection images to your inspection route so that you can do comparative review based on previous inspections right on the camera, as well as observe the camera settings from the previous inspections and make sure that you're capturing that next image or the new image in a similar angle and distance from the first inspection. So some really nice tools there, as well as we're going to be offering in about a week or so here, we're going to be offering an NFPA report template, no charge to our customer base that's using Thermal Studio Pro, that'll allow them to produce a NFPA-70B compliant report, so they're not going to need to create that report themselves. Training, right, is another component of our business where we can ensure your team is trained to properly meet those requirements. And the one I always leave off the list is our calibration services that we offer here as well, to be able to ensure that your calibration certificates and your tools are in compliance with the organization. Some advancements we're making as well, in this whole offering is understanding how can we make things easier for that inspection program. Being able to offer delta T calculations on the camera, we can do that today. In the software, we can do that today. But the combination and power of the routing within the software, being able to load a route on a camera, go out and perform the inspection activity based on a list of assets, and we need a list of assets because the requirement is there to document them all. Real powerful solution that we can bring together. We've also developed some bundles of a solution offering around all of these as well, and you can work with your ITM sellers on those solutions that combine the camera, the software, and the training into a simple package that you can look to purchase to work on the 70B requirements. So with that, I think Chris, we are kind of at our marker here for time, and just wanted to hand it back over to you for questions from the group.
Fantastic. Well, first, before we go into anything, John, thank you very much for the presentation. We mentioned earlier, there's a lot of content, a lot of stuff that we did cover. We have about 10 or so minutes to try to get to as many questions as we can. If we don't have a chance to get to your specific question, we will address it with you directly offline. So let's take advantage of having an expert like John with us today. Just a quick note, if you have any product specific questions, whether it has to do with some of the IR windows we spoke about today, the cameras, something that will apply to your specific application or your specific requirements, I invite you to go to globaltestsupply.com. There you'll find our list of products, prices, availability, technical data sheets, etc., along with the many ways and different ways that you can contact myself or our team. That includes phone, email, or live chat. So we did get a few questions come in throughout the presentation, a couple referring to getting a copy of this presentation. Give our marketing team about a week or so. It will be posted on the training section of our website at globaltestsupply.com, and in the subdivision, the training section. So, all right, let's get right on to it. John has a question about, okay, if the equipment that I'm measuring or that I need to measure, I'm unable to remove the cover for thermal inspection or thermal measurement. If I shut down the equipment, remove the cover, and take the image, would that be considered a live reading?
Technically, no. But I do know some scenarios where that may certainly present itself. I think if you properly documented that and were able to execute the thermal capture within a reasonable amount of time, and that's going to vary based on your operational environment, but that's certainly something that the letter of the guidance doesn't allow for that. It needs to be under load while it is being tested. But if you can document the situation as such, then I would say you're likely going to get a measurement that you can compare effectively over time with previous inspections or similar assets under that same condition. I would just write that up very explicitly in your test procedures, so you have your window of time clearly defined. It can be no longer than 2 minutes after the cover is open, those things like that. But the guidance does say under load.
Perfect. Next question from Tracy. Do you know any Class 1, Div 1, or Div 2 rated windows?
So you broke up there at the end, Chris.
Oh, Tracy is wondering if there are any Class 1 Div 1 or Class 1 Div 2 IR windows.
Class 1 Div 2 IR windows, I would have to get back to you, Tracy. I know we have a Class 1 Div 2 camera. We have an EX rated camera, our CX5 camera. can operate in Class 1 Div 2 environments, but as far as the window themselves, I don't know.
Perfect,
But
no problem.
I can get back to you on that. And certainly within our data sheets on the website or Global Test Supply website, I'm sure they can call that out specifically.
Yeah, definitely. Tracy, we can address that directly. Let's see. Okay. So when installing and or when looking at possibly adding or installing an IR window, does the installation process or the changes made to the box itself change the characteristics of the box itself?
Yeah, so that's a great question. UL certification always comes up with this. So our devices or the component themselves, the IR windows are UL certified as appropriate to use in those applications. What the organization will need to do, and this is typically our recommendation, there's a couple things I want to call out specifically. On our round IR windows, our mounting process does allow for a screw back type installation. So there are no additional penetrations beside the punch out, right? That's a unique component to our IR window. And two, what we recommend is when an organization is looking to install a series of IR windows in the organization, they can get their cabinets recertified. So you need to contact UL and have a representative come out to recertify all of the cabinets as recertified. But we have never had an issue with an organization that's done that to get them recertified as safe.
Perfect. Another reminder, we've got about 5 minutes or so left for questions, so please get them into the question section. If we don't have time to address them, we will address them directly offline. Do you know the specific section of 70B that requires thermal imaging certification?
Yeah, do.
And if we can't pick it up, maybe again, I can grab it from you, John, and I can answer James directly.
As far as the certification, that would fall under 4.3.3 is the section. And 8.4.1 addresses testing personnel to be qualified to operate and test equipment. So to be clear, it does not specify level 1 thermography certified. It's encapsulating all test equipment within their guidance and shall be qualified in the language within 70B is a certification of operation. So with that level 1 certification, we offer a variety of different certifications for level 1 through our infrared training center, one of which is level 1 electrical certification, which actually very closely aligns with the type of equipment and how to properly inspect electrical equipment with thermal tools. And that's typically the course that we recommend folks take that want to become qualified for that activity.
Perfect. And we did have a question about the difference and or offerings between the different levels of thermography certification and or specifically anything for electrical inspection. So that was a great 2-for-1 answer there. Josh had a question specific to demos and stuff like that Global Test Supply or in conjunction with Teledyne FLIR that we can offer. Josh, let me take that directly offline with you. We'll get the sales rep in your location to contact you directly, and we can take care of that with you offline. Next question from Chris. Do these NFPA requirements need to be followed for a program within a facility that we maintain, or is there a difference between, I guess, own maintenance and third-party maintenance and scanning?
Yeah, if you're the owner of that facility, ultimately the responsibility lies with you. If you are a tenant in a facility that operate assets that the owner is only providing building services up to, anything post building services you would be responsible for anymore because typically the owner of that space does not maintain that equipment. So thinking of like a tenant fit out in a commercial facility where they may have additional motors and electrical systems, you as the occupier of that space would be responsible. And there was a question that's come up in the past as well relative to this, to understand, this is strictly in the commercial and industrial side, right? This does not apply to residential, but it does apply to organizations. And the way I best explain it is if you have any sort of step down capability in your building from a high voltage line coming into your building, and you're transforming that electricity to medium and lower voltages, this applies to you, right? So if you're high kV coming in, transformers, step downs, you're going to need to have this program in place for compliance.
That's perfect, and I think that leads us perfectly into being respectful of everyone's time today. Again, if you have a question in the next couple of seconds, couple of minutes that we are not able to address directly, throw them into the question feature. We will draw all the questions from there and contact those people directly that we should or that we feel that we need to follow up on. If not, and this closes and you have that light bulb moment where you have a question, go to our website, globaltestsupply.com, the contact us page. Contact us via phone, live chat, email. Myself or one of our experts will be happy to help you and guide you to the best possible solution for your specific application and or your specific question. So on behalf of Global Test Supply University, I want to thank every one of you for attending today. We hope you found it informative and helpful. As mentioned, we're available to assist you in any way that we can. Go to globaltestsupply.com. You'll find the product list, all the cameras we talked about today, or all the options of cameras that we kind of alluded to today, the IR windows, all the spec sheets to go and figure out whether or not they're Class 1, Div 1 certified, etc., along with pricing, availability, as well as our contact info along with it. At the end of this webinar, we have a short survey that we'd encourage you to complete. Your feedback will go to assist us in improving these webinars, as well as bring topics that are of interest to you as well. We do have upcoming webinars over the next few weeks and months. If you go to the training section of globaltestsupply.com, you'll find all the upcoming webinars, as well as a list and links to all the previous webinars we've done over the course of the last, I believe, year, 18 months or so. And don't forget that as a thank you for attending the webinar today, your name will be entered in a draw to win $100 on your next online order. The winner will be announced on our social media channels, so please be sure to check us out there. Again, a big thank you to John for the presentation and sticking around for answering all our questions today. Another big thank you to all of you who attended. Wishing you all a great rest of the day.
Thanks, Chris. Thank you, everyone.
Take care, everyone.